Yes, hello. So, how are you all? My name is Yogesh, and we are doing Statistics Standard 12, Part 2, Chapter number 1, Probability. This is my 13th lecture, and you have to see all the previous lecture to watch this lecture because everything is in a sequence, in a link. We have so far completed illustration 11, 12, and 5 sums from exercise 1.2. Today I'll be teaching you illustration number 13, and as I told you in previous lectures, this lecture is important, today's lecture, because we are doing a bit new topic in the probability. Okay, in probability there are many small topics. It is a bunch of all the small topics, and you have to pay attention in that in which sum how the treatment is to be done. Okay, let us read the illustration number 30. Find the probability of getting R in the first place in all possible arrangement of each and every letter of the word Rutva. So what you are asked to find the probability of getting R in the first place in all the possible arrangements of each and every letter of the word Rutva. So what I'll do, first of all I'll write the question here. Okay, let us write question here, illustration 30. Find the probability of getting R in the first place in all possible arrangements of each and every letter of word Rutva. You have to find the probability of getting R in the first place in all possible arrangement of each and every letter of word Rutva. Now, what you have to catch in this sum, that there is a talk about arrangement. What it is talk about? Arrangement. Now, what this arrangement is, sir? I told you that arrangement means it's permutation. Arrangement means it's permutation. Okay, arrangement means permutation. Okay, now this permutation and combinations is the chapter of standard 11th, number 6. Okay, you have to know some basics of this chapter, else you have to learn here what I am teaching. Okay, see, you have to find the probability of getting R in the first place in all possible arrangement of each and every letter of word Rutva. First of all, there is a word Rutva. Okay, so you can see this is 5 letter word. If I want to arrange this, if I want to arrange this 5 letter words, Rutva, then what are the total possibilities? As I told you in probability, we'll always be finding n first. We'll always be finding n first. So what are the total possibilities? Total possibilities are 5p5. 5 letters, 5 places. Okay. How we'll solve this 5p5? It's always 5 into 4 into 3 into 2 into 1. So total there are 120 ways that I can arrange the word Rutva. How many ways are there total? 120 ways are there that I can arrange the word Rutva. Okay. Now what this you got n. Okay. Yes, so there are 120 ways to arrange this word Rutva. Okay, now what you need to find? You need to find probability of getting letter R in the first place in the possible arrangement of word Rutva. So let us assume. So let event A be the event of getting R in the first place. Now total there are five letters. One, two, 3, 4 and 5. You are asked to put R in the first place. You are asked to put R in the first place. So now if you are asked to put R in the first place, the possibility of putting R here is 1p1. One letter R and first place, that is one place. So one letter and one place, that is 1p1. Now you have put R in the first place. Rest 4 there is no condition. They have only told that R should be in the first place. Rest 4 there is no condition. That means rest 4 letters can be arranged in any way they can. That means UTVA, V, UTA, VATU, VT, UA, okay, UTAV, whatever. Okay, rest 4 can be arranged in as many as ways as possible. So what are the rest possible ways? Rest possible ways are 4p4, 4 letters and 4 places. Okay, what rest are possibilities are there? 4p4. So total possibility here are 1p1 into 4p4. What are the rest possibilities? It's 1p1 into 4p4. So it's 1 into 4, that is 1p1 is 1, 4p4 is 4 into 3 into 2 into 1. So it's 24. So your probability is m upon n, 24 by 120, that is 1 by 5. Okay, it's 24 by 120, that is 1 by 5. Now let us take some from exercise. So we are taking sum number 6 from the exercise. Find the probability of getting R in the first place and M in the last place when all the letters of word random are arranged in all possible ways. So we are doing exercise 1.2 sum number 6. What was the question? Word random is arranged. Okay, what you need to find? You need to find the probability of getting R in the first place and M in the last place. You have to find the probability of getting R in the first place and M in the last place. So now in this question there are two conditions. They want R in the first place and M in the last place. What we'll do, first of all we'll arrange this RANDM random. Okay, first of all we'll arrange this RANDM random. So what are the total possible ways to arrange the word random? Total there are 1, 2, 3, 4, 5 and 6 letters in the word random. So total possibilities are 6p6. Okay, there are total 6 letters, so total possibilities are 6p6, 6 letters and 6 places. So in how many ways you can arrange this? You can arrange this in 720 ways. So you can arrange this word random in 720 ways. Yes. Now what you need to find? You need to find probability of getting R in the first place and M in the last place. You are asked to find R in the first place and M in the last place. So let A be the event of getting R in the first place and M in the last place. So total there are 6 places: 1, 2, 3, 4, 5 and 6. Now what you are asked to put R in the first place. So let's put this R in the first place and this M in the last place. So now if R is in the first place, the possibility of R in the first place is 1p1. Okay, the possibility of R in the first place is 1p1. One letter R and first place is one place, so it's 1p1. The possibility of M in the last place is again 1p1. Okay. Now, what are the rest letters? Out of 6, you can see 2 places are filled up. Rest 4 places are there and there is no condition about that rest 4 places. That means in rest 4 places, any letter can come. Okay, what letters are left? It's A and D O. So it can be arranged in any way: A and O D, A and D O. Okay, A O D N, A O N D, D N A O, and whatever ways are. Total, how many ways will be there? There are 4 letters and 4 places, so it's 4p. Okay, there are 4 letters and 4 places, so it's 4p. So the total possibilities is 1p1 into 4p4 into 1p1. So m is 1 into 4 into 3 into 2 into 1 into 1. So this is your m. If you calculate, your m is 24. So what is the probability? What is the probability? Probability is m upon n, that is 24 by 720, which is 1 by 30. Okay. Then let us find seventh one. Find the probability of getting vowels in the first, third, sixth place when All letters of the word orange are arranged in all possible ways. So we are doing exercise 1.2 sum number 7. What is question? Its word orange is there. Its word orange is arranged. Yes, orange is arranged. What you need to find, what is the condition given? Find the probability of getting vowels. You have to find the probability of getting vowels. You have to find the probability of getting vowels. In first, third, sixth place. In first, third, sixth place. Yes, this is your condition. Okay. Now, as I told you that when word orange is arranged, so what is word? It's ORANGE. Okay, it's six letter word. So you can say total possibility is 6p6. That is 6 into 5 into 4 into 3 into 2 into 1, which comes to 720. Now what you are asked to find the probability of getting vowel in first, third and sixth place. So let A be the event of getting vowels in first, third and sixth place. Okay, so you have to find let A be the event of getting vowels in first, third and sixth place. So total there are 1, 2, 3, 4, 5 and 6 places. Okay. Now, uh, now this what is asked to you that you have to put first, third and sixth place vowel. So what is first place? This is the first place. What is the third place? This is the third place. And this is the sixth place. So in this three places, there should be three vowels. Okay, in this three places, there should be three vowels. That means your M is 3P3. Three places, three vowels. Now, if you have paid attention here, then you would have noticed that in previous questions, I have done 1P1, 1P1, 1P1. In that particular question, it was clearly mentioned that R should be in the first place, M should be in the last place, this should be in the first place. It was clearly mentioned. Here it is not mentioned that O should be in the first place, A should be in the last place, E should be in the last place. No, it is not mentioned. If it would have mentioned that O in the first place, then I would have written 1P1. If it would have mentioned that A should be in the third place, I would have kept 1P1. But it is mentioned not specifically but generally that O, A, E, three vowels, three places. So I have kept 3P3 instead of 1P1, 1P1, 1P1. I hope you are clear. Else you can repeat and listen. Now, what letters are left? There were total six letters. Three we have done. 3 are left and 3 places are left, so the rest is also 3p. So your answer is 3 into 2 into 1 into 3 into 2 into 1. So it's basically 6 into 6, that is 36. Okay. So your probability is m upon n, 36 upon 720, that is 1 upon. Okay, so your possibility is 36 upon 720, that is 1 upon. Okay. Now let us find the solution for eighth question. Let me read the eighth question. Five members of a family, husband, wife, and three children are randomly arranged in a row for a family photograph. Find the probability that husband and wife are seated next to each other. It's exercise 1.2, sum number 3. It's sum number 7, I guess. It's 8. Done. Now, what is the question? Five members, husband, wife, and three three children are five members, husband, wife, and three children are okay. So five members, husband, wife, and three children are arranged. What is asked to you? You are asked to find the probability that husband and wife are seated next to each other. Okay. So you are asked to find the probability that husband and wife are seated next to each other. Okay, husband and wife are seated next to each other. Now let us assume that husband, wife, and three children are there: C1, C2, and C3. So in total, five peoples are there. If you need to arrange this five peoples, then total possibility is 5p5. That's 5, 4, 3, 2, 1. That is total 120 ways are there to arrange these five peoples. Okay, how many total ways are there? Total there are 120 ways to arrange these five. Now what you are asked? You are asked to find the probability that husband and wife are seated next to each other. So let A be the event that husband and wife are seated next to each other. Okay. Now, whenever you are asked such questions like seated next to each other, that means this is asked like two particular objects should be together. Okay, husband and wife are together. So I am teaching you this topic once, and it will apply to all. Whenever you are asked like two things should be kept together. Okay. Now, what this concept actually is, let me tell you. What is it? Suppose there are five pens. Okay, I hope it is visible. There are five pens. Okay. Now, if you are asked to arrange this 5, then there are 120 ways. As I told you, you can arrange like this, you can arrange like this. Okay, you can arrange like this, you can arrange like this. Okay, there are total 120 ways to arrange this 5 pens. Now, what is condition? Condition in that the husband and wife should be seated next to each other. Okay, so let us assume these two black pens are to be kept together. These two black pens are to be kept together. So whenever you are asked to keep two things together, then what you will do? We'll tie a knot to these two things. What we'll do? We'll tie a rubber band to these two. Now these two are together. Now if you'll arrange this to any place, these two will be together. You can arrange it anything. I have knotted a rubber band here, so this two will not be separated. This two will move like this. Now if you visible it, if you see it clearly, these two are not two, these two are one, because I have tied a knot. Now they are together but they are one. So this is one pen, this is two, this is three, and this is four. So this is treated like this. There are only four pens: one, two, three, and four. So whenever you are asked that two things are seated next to each other, then what you will do, you will treat that two as a one. You will treat that two as a one. Total there are 1 2 3 4 and 5 places, and you are asked that husband and wife should be together. It's husband and wife. So what I'll do, I'll tie a rubber band over here. Now total how many persons are there? This is 1, this is 2, I'm counting it in reverse side, this is 3, this is not 4 and 5 persons, these are only 4 persons. Okay, so your possibility is, so your possibility is 4p4, but answer is not here, it doesn't end here. You are asked to keep husband and wife together. If wife is in the first place and husband is in the second place, it is okay. You got my point. You are asked to keep husband and wife together. It's not like you have to keep husband first and wife second. Yes, you can keep it alternate: wife first, husband second. It is same as husband first, wife second. Both are together. Okay. It doesn't matter who is in the first place. Either it can be as the husband, it can be wife. So what my point is that you can exchange husband and wife. In my example, in this pen, I have told you that this two black pen should be together. I have not told you that this gray cap pen should be on left side. It can be in right side also. So this two can interchange. You got my points? And husband and wife can interchange. So it's 2p2 again. Two can interchange. So two possibilities and two places. So you will multiply 2p2 here. You got my point? You will multiply 2p2 here. So it's 4p4, that is 24 into 2, that is 40. So my probability here is, m upon n, that is 48 upon 120. It's 24 twos are and 24 fives. It's 2 by 5. Okay, you can name it, you can keep it as 0. Okay, so you got my point. Whenever you are asked to keep two things together, you have to treat it as an one, and it can be interchanged. So you have to multiply 2 by 2 more. Okay. So that's it for today's lecture. We'll be starting next sum from the next lecture, and obviously my every lecture here is important. Okay, as far as your this probability chapter is concerned, you have to thoroughly write and learn. Okay, each and everything. You have to do this chapter almost 3 times so that you can learn it properly. Okay, this is the easy chapter. Just you have to pay attention to the logics what I teach you. So that's it for today. Thank you.